Hello and welcome back for the second part of section 3.1. We did the product rule the last time. This time we'll look at the quotient rule. Make sure you've got the product rule down solid. I'm going to point out the differences between the two, and you have to be careful. There are about 2 or 3 differences that are significant, and I've got a little tune for you to help you remember how to do it. Before we start, let's get the pen going here, red, and it looks as though we're go. Alright, so this small picture below here of how the quotient rule works, we'll get back to that in a minute, but notice there's a function on the top of fx, excuse me, and a function on the bottom. Numerator, denominator. Call them what you like. One of the examples or prototypes shows h of x with an f of x on the top, g of x on the bottom. That's the way I usually think about it, but whatever works for you is what's best for you. So, quotient rule, let's go to it. This is part B of section 3.1. And we're going to find the derivative of a rational function. That means you've got x's on the top and x's on the bottom. So here we go. This is the quotient rule. The first thing to notice is that here is our function, and they're using the typical f of x function on the top as the numerator and g of x function as the denominator. Excuse me. Now, the way to remember this is, or one way at least, is start with the denominator. That's what I always do when I'm using the quotient rule. I remember we're doing quotient, so I ought to start with what's on the bottom. So start with a function on the bottom, g of x, and then we never put g of x and g prime of x together. Instead, g of x times f prime of x. And on the second part, you'll have f, and then g prime of x. Notice that this is a little bit similar to the product rule, where you have each function multiplied times the derivative of the other one. One difference is that for the quotient rule, you've got a minus in the middle. So that's one thing you have to keep in mind. The other thing is you have to start with the denominator first, the original denominator, g of x. Once you get that, you can get this part is sort of similar to the power, or the product rule, excuse me. G of x, f prime of x, minus, because the quotient rule instead of the product rule, and f of x times g prime of x. And in the denominator, here's another unusual thing. We've got the denominator squared. So, the top, you have to remember that g of x comes first, the denominator itself. You have to remember there's a minus sign. The 2 halves of the numerator are similar to that with the product rule. And on the bottom, you have the square of the denominator. Now you might like doing this. dy dx will use the same notation there. And a shortened version of that, you might put this way. Start with the denominator, multiply it times the derivative of the numerator. Always start with the denominator. Because the quotient rule is a minus, not a plus, then we reverse the roles of these two. So we'll have f for the second part, and g prime for the second part. And last of all, the third thing you need to remember is that denominator gets squared. So again, start with g, make sure there's a minus sign, and make sure you square the denominator. Those three things are critical. Okay, I guess before we do that, we have one other thing. So there's what's called a mnemonic device to remember how to get these things all straight. And it goes something like this. Now, I'm not going to sing this exactly, but it'll sound sort of like it. Low-DeHigh minus high-DeLow over the square of what's below. Low-DeHigh minus high-DeLow over the square of what's below. Okay, so what does that mean? Well, it starts out low, which means in your original, what is on the low part of that fraction? Low. D-high means the one that's on high, the D for derivative. Minus high, D low, over the square of what's below. Low, D high, minus high, D low, over the square of what's below. Some people really go by that. Low-DeHigh minus high-DeLow over the square of what's below. If that helps you, you got it. Let's try finding the derivative of this function. Now, your book, as well as some of the others, have a small suggestion that you might want to use to begin with. First of all, here's your y. That's your rational function. Function on the top, function on the bottom. And we call that f, and that's g. Now, what they suggest is, before you get started on the quotient rule, or even the product rule for that matter, write these down. So f of x would be what's on top, x squared. No big deal. While you're at it, you know you're going to take the derivative of that, so why not write it down? There's the derivative of the top. Excuse me. Same thing for the bottom. What's the function on the bottom? 5x plus 1. And while we're at it, we'll just get the derivative of what's on the bottom as well. And of course, simply a 5. Now, what's the derivative going to look like? Well, if we write it down this way, low, d-high minus high, d-low, over the square of what's below. Now all we need to do is fill in, because we've already done part of the work for us. So the derivative is, now just fill in. G is right here. So 5x plus 1, nice big fraction bar there, times what? The derivative of f. We've already got it, 2x. We're using the quotient rule, so there's a minus between them. What's on the second part? F itself is right here, waiting for us, x squared. And g prime, we've already got g prime ready. There's our 5. Over the square of what's below. What's below is 5x plus 1, which is, again, right there, but we need to square it. So 5x plus 1, quantity squared. And we're ready to go. All that's left is a bit of algebra, clean up, so here we go. dy dx should be the same as what I wrote down earlier. Here's the, oops, where am I? Here. There's g, f prime, minus, because I'm using the quotient rule, I or f, and g prime, and there's the square of g. We're ready to go. Multiply those out, a little bit of simplification, and we've got it. We have got the derivative of y with respect to x using the quotient rule. A big reminder, because the minus sign, the order of the terms in the numerator is critical. That's why when I'm doing the quotient rule, the first thing I want to think of is g, the function on the bottom. Write that down first, and for me, everything follows. As soon as I write down g, then I know I have the derivative of the second one. I know it's a minus because of the quotient rule. Then reverse these roles, f, g prime, and of course my weird g squared on the bottom. And start filling in the blanks. I do like that method of putting down f and g and f prime and g prime before you get started. That way you don't get too many things going at one time. Simplification can be complicated enough. So here's another one. We're going to do this, and we're going to use the quotient rule, and we'll simplify, and we'll end up by using negative exponents. So here f of x represents the entire quotient. If I were going to do this myself, I might temporarily call this h of x. That's entirely up to you. As long as you remember low-DeHigh minus high-DeLow over the square of what's below. If you've got these four functions and derivatives ready to go, you can plug them in. So here we go. There's the denominator. There's the numerator derivative, the original numerator, denominator derivative, and we've got the minus sign between them. We've got them in the correct order because we started with the denominator, we've got the minus sign, and down below we have the square. The three things to remember. Start with g, put a minus sign in there, do like you did with the product rule, and make sure it's g squared below. Here's a nice setup. I like this idea. That way you don't have to think of too many things at one time. So there's some simplification. Just multiply those things out. Make sure that after you multiply these that you change the sign because of the minus sign. Just a simple reminder. And then add similar terms together. Don't forget the minus sign again. And that's all we've got. X squared minus 2x all over x to the fourth. Notice the denominator of the derivative usually is going to have a rather large degree compared to all the rest. Another way of writing that, because we'll be able to reduce that to this. which is pretty nice. But notice the denominator was a single term. That means there's another way we could write this. So instead of writing it the way we just did, we might want to split one up like that, because having the x squared in the denominator means it's being divided into all three of those, like this. And each one of those, well, two of the three can actually be reduced. So we can write it like this. It all depends on what the actual function is, how we're going to use it. This might prove handier, or this might prove handier. And the second way of writing it is use the negative exponents if you like. It's your call, really. What you need to remember, though, is if you're working with someone and you're comparing answers, your answer and your partner's answer might not look the same, even though they're both totally correct. So keep that in mind, too. That can happen. So there's a second way of writing one. Different forms of the same answer. And they're exactly the same as far as function is concerned. Excuse the pun there about functions. Those are the same thing. Now here's an example of bacteria. So before you do this, you might want to hit the pause and go wash your hands, and wash your hands afterward, just in case. Notice first of all, what you got here is a rational function. You got t's on the top, t's on the bottom. So you're going to want to use the quotient rule. And after you get the derivative, eventually, then you're going to find what the value of that derivative is, or the rate of growth, after 4 hours. So you take the derivative of n of t. When you get the derivative, you put the 4 in where the t's are in the derivative, and you'll get your rate of growth. So here we go. N of t. There's your original. So rewrite it, because we want it ready for our power rule and the quotient rule. So here we go. We've got a function on the top, function on the bottom, f of x on the top, g of x on the bottom, if you so choose. So here we go. Our derivative of n with respect to t, and just as a small reminder, another way of writing this, our friend Leibniz would say, is the derivative of n with respect to t. That's how t is changing for every change of 1 t. So this might be in seconds, hours, minutes, whatever, but one of those seconds, hours, seconds. And there we go. Since I'm using the quotient rule, remember this is in the denominator, this is the derivative of the numerator, minus because we're using the quotient rule. There's the numerator, there's the derivative of the denominator coming up, and we squared the denominator. So we're ready to go. So we've taken the derivatives, we're ready to multiply, and instead of taking it further, we keep this last part, and instead of multiplying that all together, since we're only going to put 4 in once, we're not going to put several things in, it turns out it actually might be easier in this case So just go ahead and put the 4 in. Each one of those turns out to be pretty easy. Remember, 4 to the 1/2 power means square root of 4. Square root of 4 over 1 for this one. Go through these very carefully. There's the 2. There's the 1. This gives me the 9. There's our minus sign. 4 squared plus 4. That's our 20. Got the 1/2 there, 1/2 here. And we've got 4 to the 1/2 power, the minus. So it'll be 1 over the square root of 4, which is 1 over 2. Put those together. 3 times 9, 20 times 1/4. Put those together, and there's just about our answer, except that, remember, we want the rate of growth of the bacteria. 22 over 9 wouldn't make sense if we were talking to someone about how fast the bacteria are growing. Instead, decimals probably would make a lot more sense to someone else, or to ourselves for that matter. 2.44 bacteria per hour. Make sure you get the bacteria in there, make sure you get the hour in there, and it's a rate, so it's per. Now, I also mentioned this, we didn't bother to simplify because we're just using t equals 4, and this works just as well as any other way we'd do it. Next, suppose f and g are differentiable functions, and we want, these are 2 different questions using these values. So take this out of your mind for the time being. You want to find h prime of 5 for the first one. So remember, you're going to have g times f prime minus f times g prime on the top. But you've already got those numbers. So if I just write it this way, g f prime minus f g prime over g squared. G is, remember, we've got a 5 in there, so g, there it is. G of 5, remember we're putting 5 in for the x's. So this, right here, this g, becomes negative 3. F prime, that's f prime of 5. F prime of 5 is right there. Got a 1. We've got a minus between them. Now we need f of 5. F of 5 is right there, 10. And g prime of 5 is right there, an 8. On the bottom, notice this isn't a derivative, it's just g squared, and g of 5 is negative 3, so it's negative 3 squared. And we're ready to go. So negative 3 times 1 is negative 3. 10 times 8 minus 80. And on the bottom we'll have a 9. Negative 83 over 9. Convert that to a decimal perhaps. And we'll have 9.22. And notice we've got a minus, so should end up with that. Exactly. Negative 9.22. Remember, that's the first part. Now we're going to do something similar, but we're going to work with this problem instead. this is a different h of x. And there's a cleaned up version. We want h prime of 5. So we'll just fill in those values we already had. Remember, back here at the top, we had this list of function values and derivative values. Just bring those forward and fill those in so you get h prime of 5. So we're going to need f prime of 5 here, just a 3, g of 5, g prime of 5, f of 5, 3x minus 1, and of course the x will be a 5 because of this, and fill in the blanks. Simplify a little bit, and a little bit more, and a little bit more. And there is our derivative. Not too bad, right? If you like, go back and run through it again. It's good practice before you actually try working exercises yourself. So this is a caution. Be careful about this. There might be several correct ways of writing your answer. So if you're comparing your answer with someone else, or for example, if you're checking to see whether your answer is correct in the back of the book, say you're doing number 17 and you've got an answer. If what's in the back of the book doesn't look exactly the same, that doesn't necessarily mean you're wrong. What you might need to do is check and see if you can adjust your answer so it looks like the one in the back of the book, or your partner. So here's an example of two different answers. They look quite different, but both those can be converted to that. So actually what looks like two different answers up here actually turns out to be okay. Alright? So just watch out for that, because that's a simple thing that can happen. In fact, it's not just in calculus. That can happen in algebra, a lot of different places. So that is the quotient rule. Bring any questions you've got on this or from the exercises you're working. Bring them to class and we'll get you on track with your derivatives of quotients. Until then, and by the way, no, this isn't for the Olympics, no. That's a reminder that the next step in our growth is going to be using the chain rule. That's supposed to represent a chain. Not too great, but it's a reminder anyway. Okay, see you soon. Bye-bye.